Hey everyone, and welcome to this new video. My name is Miguel. I am a network engineer, and this time we're going to be talking about 4 tools that every network engineer and IT professional should know how to use. Let's get started. So one of the first tools that I want to talk about is one that you most likely know, and this one is PIN. PIN is one of those tools that you probably have come across, and it's going to be very useful to troubleshoot network issues. What it does is essentially sends 4 requests, and we're expecting to receive 4 replies. We can change the amount of reply requests that we send, but by default, this is how many that we'll send. We can either do and ping a IP address such as 8.8.8.8, or we can ping a name such as google.com, fully qualified domain name. And if we look at the output from PIN, PIN is going to give us some really good information. So in this case, for each PIN, we're going to get a successful reply. If this was successful with the public IP address, the amount of times in milliseconds that it took to be responded, and it gives us some other interesting parameters here, such as loss and the approximate time for round trip, and really good information. What I like the most about PIN is that it's a very simple but powerful way to check from our OSI layers from 1 to 3. It essentially tells us that our physical layer is good, all of our cabling, all of our data link for network cards, and it essentially tells us that our network is good. We can reach from our network to a router to many multiple routers on the internet all the way to google.com the server and their servers on the internet, and we're getting a successful response back to us. So this allowed us to quickly troubleshoot and isolate network issues if this will be related to routing or physical connectivity all the way to layer 3. Another tool that I would like to talk to you about is going to be any tools that help us to check or connectivity. So sometimes we are able to get to their destination with a pin. We can do something like pin 8.8.8.8, and this doesn't necessarily have to be this, right? This could be any destination like our web servers, databases, or any particular place that we like to connect on our network. And what happens is routing is good, network connectivity is good, but then that port might not be open on the destination. And this is where we can use a tool such as TNC or test network connection. It's the same. This is on PowerShell, but I just like to use the short form. And we can give out the port that we'd like to connect. So in this case, let's imagine this is port 53 for DNS, right? And we can check if we have connectivity to the destination on port 53. This normally takes a few seconds to confirm. And here we can set TCP test succeeded. This is the same for Ubuntu. In Ubuntu or any Linux OS that we might be using, there's going to be multiple tools that are going to help us to achieve this functionality. But one that is widely available on most of them is going to be NC or netcat, and the functionality is very similar. We can do NC with verbose and our IP address port 53, see if that's open. We might want to check if google.com is open on port 443, and this is going to be a very useful tool to check if that TCP port is open, if that functionality is accessible. If it was a fail result, we will see something like a timeout here. So this normally takes like a few seconds to timeout, and it's very similar on Windows if we try to do it from here. It's normally going to take a few seconds, and eventually it will time out. So a very good tool, very useful, and it's going to make our troubleshooting a lot more easier to check if it's really on the network or if it's more on the destination, which is not allowing that connectivity. And sometimes it might not be the destination. Sometimes it might be a firewall in between that could be blocking that port. But this should get us on a good next step to see what could be happening. Another tool I want to talk about is going to be Traceroute or Tracer. So Traceroute is very similar to PIM. It uses both ICMP and UDP. And in this case, what it does, it allowed us to get a picture of all the devices that are between us and our destination. What it does is it essentially sends a UDP packet with a very short time to live of once initially, and it will go and start to increase it as it goes to the next hubs. So what this does is because it sends this packet with a short time to live, the every device that receives that packet is going to send a packet TTL expire, and that way we can get a map of the IP addresses of all the routers that are between our source and a destination. This can be very helpful, especially when we want to isolate the issue, or we may have an issue with a router losing packets in the way, or we may want to also isolate it at that level. So let's take a look at how does this work. So if we go here and do tracer -d, this is to avoid DNS resolution just so it can be a little quicker. And we do our destination. Here we can get a good map of all the IP addresses that are between our PC and our destination server. In Ubuntu, we're going to have a very similar command, which is the actual trace route. And we can choose our destination here, and this is going to do the same. Sometimes you will notice that you don't get all the maps or all the IP addresses of the routers in between, and this is because there might be some devices here that don't support ICMP, so they won't reply when our TTL expires. But otherwise, this should be a very useful tool, and one that definitely you can use whenever you find and want to isolate network issues. Let's talk about another tool. So one tool that we want to consider and use is nslookup. And this is going to be very useful whenever you're troubleshooting DNS issues. So let's take a quick look at what is DNS. DNS is what essentially allowed us to resolve domain names to IP addresses, and it's what gonna allow us to essentially have our seamless web as we do, right? So normally we don't memorize IP addresses, we memorize names like google.com, like Facebook, like Meta, like ets.com, and then we use those on our browsers. Behind the scenes, we use DNS in order to get the IP address, and then we connect to the IP address to our networking stack. And what happens is there's a lot of DNS issues. We can have a lot of problems that can have derived from either a misconfigured DNS, either a not reachable DNS, either a record that is not replicating as expected, and many, many more. So in this case, what we can do is do nslookup and check for our desired name and see if that's available, and we can compare that. So in this case, if you use the default, it's gonna use whatever DNS server that you're using. And sometimes what can happen is maybe we're getting a different response from our default DNS or a non-existent response. We don't have a record for what we're trying to look up, and we can compare that against a different DNS server. So this is an optional parameter after the name. We can use a different DNS. This is Google's DNS IP, and this is going to use that server to give us our response or our IP addresses. Another very powerful tool that we can use on Linux OS is going to be dig or DIG, and it works very similar to an nslookup. It allowed us to check for DNS resolution in our machine. It tells us what IPs resolves to what records, but it gives us some really interesting information. Like here we can clearly see what type of DNS records this was. We can see the query that we sent, the seeds answers, and we can see other things such as flags information and just some interesting parameters that we get here from DIG, and we normally don't get to send an lookup. Um, it has a lot more functionality, and if we want to do something similar to our previous test where we use, let's say, a different DNS server like 8.8.8.8, and we want to resolve google.com, then we can do that as well here. So another good tool to keep in mind, especially if you're using any kind of Linux-based system. Hey, before you go, if you like these videos, I have a full series of blogs where I go into this and many more tools, use cases, how to use them. So I think this can be really helpful. I will leave the link in the description below. If you'd like to know more about Azure Networking Channel, I have a video about that here. And if you enjoy and like this content, please consider liking and subscribing it. So I will make more content and I will see you in the next video. Take care.